Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve Cauchy's equation. So let's get going. Problem: solve x square d square minus xd plus 1 into y equals to log x by x whole square. So we are given Cauchy's equation directly and we are asked there to solve. Given Cauchy's equation, x square d square minus xd plus 1 into y equals to log x by x. Now we'll write this equation which has or having variable coefficients to equation with constant coefficients simply by making a substitution. X equals to e power z, then log x equals to z, and also let theta equals to dy dz. For theta is a differential operator whose independent variable is x. Okay, we'll replace xd by theta and x square d square by theta into theta minus 1. Let's make the substitution now. Replace x square d square by theta into theta minus 1 minus replace xd by theta plus 1 into y equals to replace log x by z, we'll get z by replace x by e power z whole square. This becomes theta into theta, theta square minus theta plus 1 into y equals to z by e power z whole square can be written as z square by e power z whole square. Then we'll get theta minus theta is minus 2 theta plus 1 into y equals to z square by e power z whole square is e power 2z. Okay, which is in operator form. F of theta into y equals to some function of z. Here we can also write this as theta square minus 2 theta plus 1 into y equals to z square. We can write 1 by e power 2z as e power minus 2z. Okay, since 1 by e power 2z equals to e power minus 2z, right, which is in operator form. Where f of theta equals to theta square minus 2 theta plus 1. Now let's find yc and yp because the general solution is given by y equals to yc plus yp, right? We'll find yc using the auxiliary equation. The auxiliary equation is f of m equals to 0, where f of m equals to, we have f of theta, theta square minus 2 theta plus 1, right? Let's replace differential operator by m, so that we'll get f of m equals to m square minus 2m plus 1. Then our auxiliary equation becomes m square minus 2m plus 1 equals to 0, right? Looks like expansion of a minus b whole square. Let's see. Let's write minus 2m as 2 into m into 1 and this 1 as 1 square. So this is of a square minus 2 into a into b plus b square, an expansion of a minus b whole square form, right? So we can write m minus 1 whole square as m minus 1 into m minus 1. Equate each factor to 0. When m minus 1 equals to 0, we'll get m equals to 1. Since m minus 1 is repeating twice, so we'll get m equals to 1, 1. So here the roots are real and equal. Therefore, the roots are real and equal, right? These are the roots of our auxiliary equation, which are real and equal. Now let's write the complementary function. We know that when two roots are real and equal, say m1 equals to m2, then yc will be c1 plus c2 into independent variable into e power that equal root into independent variable. Now let's write complementary function. Our complementary function looks like yc equals to c1 plus c2z into e power equal root 1 into z. This equals to c1 plus c2z into e power z. Now we need to write in terms of x. So what we'll do, we'll just replace e power z by x and z by log x. Okay, then yc becomes c1 plus c2 into log x to the base e into, replace e power z by x, will get into x. So these are required yc. Let's now find yp, particular integral. We'll find particular integral using 1 by f of theta into function of z. That is RHS part. Okay, this is equals to, we have f of theta, theta square minus 2 theta plus 1 into z square e power minus 2z. So this is of 1 by f of theta into e power az into v form. We'll shift e power az towards left by replacing theta with theta plus a, and later we'll operate v with 1 by f of theta plus a. Right? Here we are having theta square minus 2 theta plus 1 in the denominator. We can write it as theta minus 1 whole square for our convenience. Okay? Into z square e power minus 2z. Now compare e power minus 2z with e power az, then for a equals to minus 2, we'll get theta plus a equals to theta minus 2. Right? Now shift e power minus 2z towards left by replacing this theta with theta minus 2. We'll get theta minus 2 minus 1 whole square into z square. Yp becomes e power minus 2z by 2z into 1 by, just remove these brackets, we'll get theta minus 2 minus 1 whole square into z square. Okay, this is equals to e power minus 2z into 1 by theta minus 2 minus 1 is minus 3 whole square into z square. So this is of 1 by some function of theta into z power k form. Right? Let's take the lowest degree term common from these two terms. But in the first term we don't have minus 3, so let's multiply and divide minus 3 here and write plus 3 as minus 3 as plus of minus 3 for our convenience. Okay, 1 by, in this denominator, in the first term of denominator we don't have minus 3, right, to take common. So we'll just multiply and divide minus 3 to this theta, and we'll write minus 3 as plus of minus 3 whole square into z square. This is equals to e power minus 2z into 1 by, now take minus 3 common from these two terms, we'll get minus 3 times theta by minus 3. We can write it as minus theta by 3, or better write theta by minus 3 plus 1 into z square. yp becomes e power minus 2z into 1 by minus 3 into, write theta by minus 3 as minus of theta by 3 plus 1 whole square into z square, right? This is equals to e power minus 2z by, into 1 by minus 3 into, we can write minus of theta by 3 plus 1 as 1 minus theta by 3 whole square into z square. So by doing this long process, we won't get any mistakes. Okay? In examination, you may leave minus or plus, you may get wrong answers. So it is easy to get the right answer in a right way simply by following this process. Okay? Now, is equals to e power minus 2z into 1 by minus 3 into this term whole square is minus 3 square into 1 minus theta by 3 whole square into z square. This is equals to e power minus 2z into 1 by minus 3 whole square is 9 into 1 minus theta by 3 whole square into z square. Now, we'll split this fraction as 1 by 9 into 1 by 1 minus theta by 3 whole square into z square. See, the second fraction is of 1 by 1 minus x whole square form. We can write it as 1 minus x whole power minus 2, and later we can use 1 minus x whole power minus 2 formula, which is equals to 1 plus 2x plus 3x square plus 4x cube plus so on, right? Our yp becomes e power minus 2z by 9 into 1 minus theta by 3 power minus 2 into z square, right? Now, we need to expand 1 minus theta by 3 whole power minus 2. Before heading to this step, we'll find derivatives of z square. Okay? Theta of z square is 2z. Theta square of z square. We can write theta square as theta into theta of z square, right? Again, we can write like this. We have the value of theta of z square, which is 2z. Again, we can write this as 2 into theta of z, which is 2 into value of theta of z is derivative of z with respect to z is 1. We'll get 2 into 1, 2. So theta square of z square is 2. Or by looking at this, we can say that derivative of 2z is 2. So which is the value of theta square of z square. Likewise, theta cube of z square is derivative of 2 with respect to z, which is 0, right? Likewise, we'll get the higher derivatives 0. Higher derivatives of z square 0. Okay, similarly, theta power 4 of z square is 0 and so on, or zeros, right? In general, we can write it as theta power k of z square is 0 for k equals to 3, 4 and so on. Now keeping all this in mind, okay, by keeping all this in mind, we'll expand 1 minus theta by 3 whole power minus 2. Equals to 1 plus 2 into theta by 3 plus 3 into theta by 3 whole square plus 4 into theta by 3 whole cube plus so on. This equals to 1 plus 2 by 3 into theta, or right, 2 times theta by 3 plus 3 into theta by 3 whole cube can be written as theta square by 3 square is 9 plus 4 into theta cube by 3 cube. Theta cube by 3 cube. 3 3s are 9. 9 3s are 27. Plus so on. Since we know that theta cube of z square is 0 and all the values of z square from here is 0, right? So from here we'll get definitely higher derivative terms. from theta cube, theta power 4, theta power 5 and all, right? So we can neglect all the terms from here and we'll get only the first 3 terms, or we'll take only the first 3 terms. Okay, now coming to yp. Yp equals to e power minus 2z by 9 into expansion of 1 by theta by 3 whole power minus 2 is 1 plus 2 into theta by 3 plus 3 into theta by 3 whole square plus 4 into theta by 3 whole cube plus so on into z square. This is equals to e power minus 2z by 9 into 1 plus 2 by 3, sorry, 2 into, write this step, okay, 2 into theta by 3 plus 3 into theta square by 3 square 9 plus 4 into theta cube by 3 cube 27 plus so on into z square. Since theta power k of z square is 0 for k equals to 3, 4 and so on, so neglect higher derivative terms involving or higher derivatives, easy, right? Theta cube, theta power 4 and so on. So we'll neglect all the terms from here and we'll write only the first 3 terms. Then yp becomes e power minus 2z by 9 into 1 plus 2 by 3 into theta plus 3 1s are 3 3s are 1 by 3 into theta square of z square. Now we can write yp as 1 into z square plus 2 by 3 into theta of z square plus 1 by 3 into theta square of z square is equals to e power minus 2z by 9 into z square plus 2 by 3 into theta of z square is 2z plus 1 by 3 into theta square of z square is 2, which is equals to e power minus 2z by 9 into z square plus 4, 2 2s are 4 by 3 into z plus 2 by 3. Now we need to write in terms of x. So what we'll do, we'll just replace x, e power z by x and z by log x to the base e. Before replacing, we'll write e power minus 2z as e power z power minus 2, okay, by 9 into z square plus 4 by 3 into z plus 2 by 3. Now it will be easy to replace. Then yp becomes, replace e power z by x, will get x power minus 2 by 9 into, replace z by log x to the base e, will get log x to the base e whole square plus 4 by 3 into z, replace z by log x to the base e plus 2 by 3. Since x power minus n equals to 1 by x power n, then we can write x power minus 2 as 1 by x square into, terms remains the same, plus 4 by 3 log x to the base e plus 2 by 3. Then yp becomes 1 by 9x square into log x to the base e whole square plus 4 by 3 log x to the base e plus 2 by 3. So these are required yp. Now we got yc and yp. Let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we are having c1 plus c2 log x to the base e into x plus yp plus 1 by 9x square into log x to the base e whole square plus 4 by 3 log x to the base e plus 2 by 3. This completes the problem. So we have seen a problem from Cauchy's equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.